Recording is rolling. It's Wednesday, April 8th. We do Kahoot review on Module 10 probability. So, as you tell here, you guys know quiz is Friday. Tomorrow will be an Alex day. You guys know there's an Alex assignment, 10-5, 10-6. Been open for a little bit. Quiz on Friday. Quiz on Friday is going to look a lot like this Kahoot review we're doing right now. Alright, here we go. You have 9 shirts, 3 pairs of pants. How many different outfits can you make?
I accidentally is it first one.
Yeah, 27. 27 different outfits. So I can make a table like this. Number 1. So you have 3 different pairs of pants. 1, 2, 3. 9 shirts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose you want shirt number 7 and pants number 3. That's one combination. Okay, so the total possibilities is very simply 9 times 3, 27. All right, what's on the board? Venn diagram, 99 people surveyed, 34 have a dog, 28 have a cat, 9 have both, 46 have neither. What does that Venn diagram look like?
It's red.
It's not red.
It's not red. But it's big.
Here,
It's
I mixed up the dog and the cat. I mixed them.
No.
I can't see that far.
So it's both.
I'm a toward and I can't read. They both have 3 letters in the name.
Yo.
What?
White.
Wow.
That says 39.
Oh, you gotta subtract
Okay.
the 9. You gotta have subtract.
All right.
I do it because we're
Yeah, 99 people surveyed. If you add up all the numbers, pull a calculator. Let's do 25 plus 9 plus 19 plus 46. Yeah, so all the numbers add up to 99. There's 99 people total. The last detail says 46 have neither dog nor cat. So you guys see 46 is outside the circles. Right. Now we got a dog circle and we got a cat circle. Right? Now I said 34 people have a dog, but that doesn't exclude you from having a cat. You could also have a cat. And that's why you have to add the 25 and the 9. Guess what's 25 plus 9?
34.
34. Right. And what about cats? No, 28 people have a cat, but not necessarily exclusively a cat. So what's 9 plus 19? 28. So there's all 28 that have a cat. Right? They said 9 have both. There's the intersection of 9.
Got it right. Are you proud of me, Mr. Griffin?
Yeah, yeah. All right, nice job. You got it. All right, you guys good?
You up there, man.
Yeah? All right, there you go. There's a bigger version right there. Yeah.
You're no way you can make that.
Well, because we got. Card is drawn randomly from a standard deck of 52. What's the probability that the card is either a red or a face card? Either red or face.
They had tech support. It's 32 because the black speed cards also then.
Oh, wait, it's red, not.
Obviously, it's I didn't be. Yes. Hey, look at that. Oh, no, I don't. You're gonna see number one. So you're number two. You're right. Number one and number two. One. That's one out. I got that.
Okay, so I was good. 34 out of 52 is the answer. A lot of you guys got that. Alright, so here's how you can do this. Right, probability of red or face. Right, could be probability of getting a red card plus the probability of getting a face card because you have those. Right, but you have to subtract out the overlap because otherwise you're double counting some of those, aren't you? Double counting because there's some cards that are both red and face, and you count them there, but you also count them there, so you have to subtract out. Right? So I got 26 out of 52 are red. Is that true? 26 out of 52 are red. And guess how many face cards are there?
I don't know, well.
Yeah, 12, because there's a jack, queen, and a king, and there's 4 suits. So isn't that 12 out of 52 are face cards? Right. But half of those face cards are red, which means we already counted them. So we gotta subtract, so we're not double counting. So let's put this all together. What's 26, 12, right. I'm looking at 32 out of 52. Now I left that as a unsimplified fraction.
You're in a game. I'll play you that. Well, yeah.
Alright, so probability of either or, you add the probability of each and then subtract out the intersection. There are 12 cans, 6 cans of soup, 4 cans of bean, 2 cans of pineapples. How many different arrangements can we make? So you're going to put them in a row. You're going to put them in a row. It's bigger. Oh, yeah, that'll make it. There you go.
Pretty sure I said both of
That was
fucking me.
I didn't watch it.
It's true, huh? What's the name of Oh, so that's what I did this morning.
I gotta tell that, but I'll send you.
Yeah, there's one.
All right. So you guys here, guys, it was that third formula. Oh, guys, those four formulas I had will also be printed on the quiz. You just have to know how to apply them, like when they apply and how to put them in the calculator. Okay. So we got 6 cans of soup, 4 cans of beans, 2 cans of pineapples. No, Kahoot only lets you type so many letters in the question. So part of the condition here is that each, like the 2 cans of pineapples are indistinguishable from each other. The 4 cans of beans, I can't tell which can is which. Same thing, 6 cans of soup, maybe they're all minestrone, so I have no idea which can is which, right? I shuffle them all up, I don't know which can, right? Now, I do know the difference between pineapples and beans, or beans and soup, I know that. So, what I would start out with is, if you did know each individual can, guys, here's 12 in a row. I'm going to put them all on the shelf from left to right. Aren't there 12 different cans that could take the first place? Any of the 12?
Yeah.
Now, guys, stop doing stuff. Go here. Now, once you have that established and you move on, aren't there 11 cans remaining to take the second place? Right, and once you have the first 2 established, aren't there 10 cans remaining for the third place, and so on? Right? Guys, that's called factorial. It's 12 times 11 times 10 times 9, all the way down to 1. By the time you get to the last can, there's only 1 that could take one. But isn't that 12 factorial? 12, 10, or sorry, 12, 11, 10, 9, 8, and so on all the way down. Right. But now that you know you can't distinguish between, say, the 4 cans of beans, I know which can. Right? If I take 2 cans of beans and I swap them, I'm going to consider it to be the same arrangement, which means I don't actually have 12 factorial total possibilities. Right? And how it works out, you guys might remember this from, I think before spring break we covered this, is that you have to divide by, in this case, 6 factorial for the soup, 4 factorial for the beans, and 2 factorial for the pineapples, because those are indistinguishable from each other. Okay? Now, you could multiply this, you could write out the long version of this. 6 factorial is 6 times 5 times 4, 3, 2, 1, right? And so on for all things. Right? But the calculator will also do factorial for you, which might save you some time. So let me remind you guys how to do that. Type 12 And then you guys remember this key probability PRB? Now later on today, we're going to do permutations and combinations, but for now, you guys see the exclamation right there? There's your factorial. So there's 12 factorial. You guys know how to access 12 factorial in the calculator? Right, because I just showed you. And then divide by open parenthesis, and I'll do it 3 more times. So 6 factorial, 4 factorial, 2 factorial. Well, 2 factorial is just 2 anyway. Okay. So I'm getting 13,860 unique arrangements. Unique arrangements. All right, you guys good there? Okay. Now, when you guys had this as an Alex question, some of you guys had a version that was like, if you spell a word that has multiple letters in it, how many different ways can you rearrange the letters? It was the same premise. Or, so some of you guys had like political parties, like there's like 3 members of the Green and there's 5 Libertarians, and so on. You want to arrange them. Right. So if you remember those stories, that's the same math applied to those. Right. Here we got cans of different things. All right, you guys go with cans of pineapples. All right. All right. Get points. Supports. There are 15 dogs participating in a dog show. How many different ways to award? Sorry, this is supposed to say silver. Gold, silver, and bronze. Oops. Well, I can't really zoom in more than that. Gold, silver, and bronze.
Yes. Good. The track body. What do you have? Most of them. You both roles.
Okay. Now, part of the premise of this one is that you can rank order the 3 winning dogs. There's one that's gold, and second place is silver, and third place is bronze, and those are different prizes from each other. Okay, so that's the reason I'm going to use this P for permutations rather than combinations. Okay, later on, you'll see some combination equations later on. Combinations would be like, we don't care about the rank order. I think the next question might be like, we just give 3 dogs treats, and it doesn't matter if you're first, second, or third. Okay? But in this case, it does matter if you're first, second, or third. So those are different prizes. And so I'm going to use permutations because the order matters. Okay, guys, look up here, taking notes. Okay, I'm giving you all the quiz answers. Okay, same questions on Friday. Okay. And so permutation, and those formulas that were also on the screen, those are also printed on the quiz. I just took a screenshot straight from the quiz and put them up there. Okay? So permutations works like this. So if I do this the long way, it's 15 factorial over, guys, what's 15 minus 3? 12 factorial, which is like 15 times 14 times 13 times 12, and so on all the way down. And then 12 factorial is 12, 11, 10, 9, 5. Great. That cancels out. I'm getting what's 15, 14, 13. I'm looking at there are 2,730 different ways to award the 3 medals. So you have 15 dogs participating. Say somebody's gonna get gold, somebody gets silver, somebody gets bronze. How many different ways could you award those 3 medals? 2,700 different ways. Okay. That's it. Now the calculator will do this for you. You guys remember how to have the calculator do it? Here, I'll do it right here. So type 15 for 15 dogs. Right, you guys all have this calculator out there, right? Then hit that PRB button, probability. Okay, NPR, that's the first one. That's for permutations. So click that one. And then what number do I type now? 3. There's 3 words. And oh, look, it's the same answer. It's the same answer. The calculator will do that for you. So now you have 2 different ways to it. You can follow the formula, or you can go into the calculator functions. Either way, you get 2,700 different ways to award those medals. Points. There are 15 hungry dogs. 3 will receive snacks. How many combinations of dogs can receive snacks? This one's a little different. What fun. That's really fun.
I saw the glass and they would make that.
I think that's gonna be.
Yeah. Right. Now, guys, last question versus this question. Guys, look here. Give me all the answers. Last question versus this question. It was both 15 dogs, and we're gonna choose 3 dogs either way. But guys, is this number bigger or smaller than the last number? A lot smaller. Okay? Because it turns out when you don't have to rank order, it doesn't matter. Oh, this is dog number 1, dog number 3. We're just gonna put them in a group. Right? Then there are a lot fewer combinations that are possible. So you're going to use combinations. Because when the order does not matter, you use combinations instead of permutations. So we're using combinations here. Okay. And that's a little bit different formula. So I copied it straight from the screen, which you'll have also printed on the quiz. Okay. So we'll go 15 factorial. That's 15 times 14 times 13 times 12 and so on all the way down. This 12 factorial will take care of this 12 factorial. And 3 factorial is 3 times 2 times 1. So okay. So I go 15, 14, 13. I'll say divide by 6 because that's what this is. So I'm looking at 455 different ways to award the treats to 3 different dogs. Right, guys got that?
Yeah.
Right. And before I put the screen here, the calculator can also do this for you. So I type 15 for 15 dogs. You guys can try this if you like. Go to PRB for probability. But now I'm going to scroll over from permutations to combinations. NCR C for combinations. Because I don't care about the order of the dogs. And I'll choose 3 dogs. And the calculator did it for me. That's how I get that. Is that? Okay. Right, so the previous question was permutations. This question is combinations. Okay, so suppose someday you buy a lottery ticket. And there's like 50 numbers you can choose from. And you have to choose like 5 or 6 or whatever. Okay. Guys, if you're playing lottery, do you think lottery falls in the category of permutations or combinations? Do you care about which ball was first and which ball was second?
No.
No.
I didn't even know.
So that would be combinations. Yeah, guys, combinations usually applies to lottery. Yeah, that would be like if you don't care about the order of the numbers were drawn. Right, so you guys go with permutations and combinations? All right.
No.
All right. What's the expected value of playing the following dice game? A fair die has numbers 1, 2, 5, 6. You pay $5 per roll. If you roll a 1, you win $20. And if you roll any other number, you win nothing.
I just say.
And so I'm claiming you would be losing. Actually, all those. Oh no, that's not true. Some of these I said you would win. Some of you guys thought you were going to win, but 3 of you guys realized that this is a losing proposition. Okay. So EV is expected value, and what you do is you take each outcome. So like losing, guys. Every time you pay $5, every time you play this game, are you losing $5 just off that? Okay. So you lose $5 every time you roll anyway.
But there's a chance to win 20.
There is a chance to win 20. Okay? But you have to weigh each of these by some percentage. Okay? Now $5 you're going to lose guaranteed every single roll. So I'll say times 1 as 100%, but 1 is a decimal. Okay? But guys, if you roll a 1, you win $20. But how often does that happen? 1 out of 6 times. So only 1 out of 6 times for expected value. So let's put this together. I'm going to lose $5, but pick up $20 1/6 of the time. So that's -5 plus 20 over 6. So overall, it's negative $1.67. So if I played this 100 times, I keep rolling this die over and over and over 100 times, then how much money should I expect to have netted at the end of 100 rolls? Yeah, negative $167. Yeah, I'm losing. So this is not a game you want to play.
I want to play that.
Okay, yeah, you can play against me. Yeah.
If there's a chance to win money, I'm doing it.
Yeah. But yeah, you guys know in the long run you're gonna be losing.
Let me just show that.
Guys, isn't that how Huh?
I'm
sure that there wasn't a chance to win.
Okay, yeah, yes. There's a chance to win, but on average, you're gonna lose, right? Isn't that the business model of casinos?
Yeah.
Right? It's like, oh, I could win a bunch of money. Everybody has the story in their mind that they're gonna win a bunch of money. Every once in a while, somebody does. That's what keeps the story alive. But for the vast majority of people in the long run, yeah, you're gonna be a loser. But here's my winners: AJ, Forrest, Gian, Grayson, Leslie Goddard. Standard deck of 52 cards. What's the probability that the top two cards are both black sevens?
1 and 2, no. I didn't find it. I didn't draw. What?
All right, I'll show you guys two different ways to solve this. Two different ways.
Always punch my face.
Oh, got one winner. One winner. Okay. So here's one way to solve this. Okay. Is if you have a standard deck of 52 cards. Okay. Guys, how many cards are black sevens?
2.
Two. Guys, two of the cards in this deck are black sevens. So what's the chance that the very first card I flip is a black seven?
1 and 50.
No, not 1 in 52.
It's 1 in mine.
Oh, 2 and 50.
It's 2 out of 52.
Oh, yeah.
Yeah, because there's two cards.
1.
So it's 2 out of 52. And suppose I do flip the first card, and it is one of the black sevens. Maybe it's the seven of spades. Right? Now, how many cards are remaining in the deck?
51.
51. And how many of those would include black
1
sevens?
out of 50.
Yeah, only one, because I pulled the other one. Okay, so it's 1 out of 51. Because if you multiply those probabilities together, you get exactly the answer. Oh, you can reduce this a little bit. Isn't that the answer right there? Okay. Now, there is another way you can also solve this. Because, guys, do I care about the order? Do I care if I pull the spade first and then the clubs, or the clubs and the spades? They could be in either order, which means that you could solve this with what? Permutations or combinations? Combinations. Guys, I think this is 52 cards. We're going to do combinations. We're going to choose two. And I want to say, how many different ways could you do that? And then the chance that, like, how many combinations would it be? And then pulling the two black sevens is, there's, well, that would mean you, I mean, there's only one way for that to happen. If you don't care about the order, it could be spades and clubs, or clubs and spades. Okay, so you're gonna say 1 out of that. Okay, so that would be 1 out of, and then what's 52? Choose 2.
Now I can't use
So
this idea.
let's try this in the calculator. Do 52. Go probability. Go to NCR for combinations, and then choose 2. Guys, my calculator should say 1326. As in there are 1326 different combinations, 2-card combinations to draw out of the deck. Yeah, that's exactly it. And then the chance that they happen to be the two black sevens is 1 out of that. Right? Right, you guys good there?
What did you say? They see me boning. I was waiting for me.
AJ, Forrest, Gian, Grayson, Lucy Godfrey. What's the probability of getting all 5 numbers correct in the following lottery? We have a lottery question. Okay. We got 20 balls numbered 1 through 20. You have to choose 5. What's the probability of getting all 5 correct?
That's bad. I didn't want family.
Is that the specific order or no?
Yeah, guys, do you care about the order? No, it doesn't matter. So whatever numbers you choose, whatever numbers to pull up out of a ball machine, yeah, it doesn't matter the order. Yeah. So you guys get that.
I'm a
So show you guys this here.
15.
All right. So I'm gonna start with the question of like how many different type tickets could you sell? Right. And if there are 20 balls and you choose five, or 20 numbers and you choose five, right, then that's gonna be combinations. Okay. So type 20 for 20 numbers to choose from. Then go to NCR for probability NCR for combinations. We're gonna choose five. That's 15,000 different type tickets you could sell. Okay. Therefore, the probability of getting the correct combination is 1 out of 15,000. Just like that. Okay. Hey guys, I'm going to do a little extension on this one. We're going to go a little deeper because I remember what the last question is. That's to say the next question. The next question is last question. Okay. And it's going to be what's the probability that you get some of the numbers correct, but not all the numbers correct. Okay. And I think you'll be able to get that if you see this just in a little bit more detail. Right, so the probability of getting all five numbers correct is the same as this. It's 1 out of 20 choose 5. Okay. But then in the numerator, I can get more specific. Okay. Guys, if there are 5 numbers that are being chosen and I choose all 5 correctly, isn't that like 5 choose 5? Isn't that true? Okay. And if there are 20 numbers to choose from and 5 are correct, then how many numbers are incorrect? 15. So I'll say multiply by, and out of those 15, how many ideally do I want to choose? 0. Yeah, I want to get 0 incorrect and all 5 correct. Isn't that true? Okay. Hey guys, watch this. Actually, try this yourself. Type 5. Everybody's got this calculator. Type 5. They go to probability, go NCR for combinations, 5. Okay. So if there are 5 correct numbers, and you have all 5 on your ticket, you're looking at your ticket, you're looking at the screen and say, oh, they match. How many different ways can that happen if you don't care about the order? 1.
No.
1. That's it. There's one way to get all 5 numbers correct. You have all 5 correct numbers. Okay. Now watch this. Type 15. Type 15 for the 15 incorrect numbers. Go to NCR. And we want to choose 0 incorrect. Okay. How many ways can you choose 0 incorrect numbers?
1.
1. Yeah. So guys, isn't this numerator just 1 times 1? Oh, and that makes this the same thing as this. It's the same thing. Which we already got just by doing 20 choose 5. Okay? But the reason I wanted to go that extra step is because the next question is going to say, what if you get 4 numbers correct and 1 incorrect? Did you guys finish writing that in your notes to set up the next question? See who's going to win the Kahoot. What if you want to get 4 numbers correct and 1 incorrect? What's the chance of that happening? I think you guys can follow the pattern and figure that out. All right, you guys ready to flip the screen? You guys got that in your notes? All right, we're going to find out how many guys can follow that. I got Forrest, AJ, Dion, Grayson. Ooh, one winner. One winner. Okay, so you guys pick up from the last question where you wanted to get all 5 correct. I'll show you guys more specifically what this looks like. But the numerator just came out to 1 by 1, which simplifies that. But now it's not going to. Because now, out of the 5 numbers that you chose, you're getting 4 correct. So it's like 5 choose 4. And out of the 15 that were wrong, well, you want 1 to be wrong somewhere. So it's 15 choose 1. Okay? All right, so let's try this in the calculator. What's 5 choose 4? Okay, and that tells me 5. Okay. So there are 5 different ways. Right? And
It says you.
one way to think is, okay, let's say there's 1, 2, 3, 4, 5 winning lottery balls that come out. Right? And there are 4 that match that on your ticket. Well, there's 5 different ways for that to happen. You might get those 4 correct, or those 4 correct, or those 4 correct, or those 4 correct, or those 4 correct. There you go. There's 5 different ways for that to happen. Okay, so that 5's coming from. Okay. Now, 15 choose 1. Type 15, probability, NCR 1. And there's 15 ways to get one number correct. Yes, there's 15 incorrect. So 15 different ways to get one of those incorrect. Okay. Then divide by 20 choose 5, which we did on the last question anyway, so we got that from before. 20 choose 5 is 50,500. Okay. All right, so let's divide by this. So the numerator is 75, denominator is 50,500. So if I do 15,504 over 75, okay, so I just did the reciprocal version. Right? It comes out to 1 in 206. That's it. Right. Let's find out who won Kahoot. Kahoot.
I didn't even answer the last question.
We got the bronze, Gian, the silver, Grayson, and the gold,
Good job,
Glizzy Goblin. Your guys' quiz on Friday is going to look almost exactly like that Kahoot, just some of the numbers will be tweaked. That's about it.